Welcome, everybody. Today we're going to be working on Module 4. A bunch of new concepts we're going to throw in today, a lot of new terminology. So I know some of you try to take notes as you go along, which I think is a good practice. Remember, you can always refer to these links as well whenever you need them. And if you look around the internet, there's lots of information on these particular topics. Uh, the first topic that we're going to look at is this concept of objects and classes. And I'm going to argue that this is maybe, one of the more important concepts that you might learn in programming overall, because most modern programming right now is based around what we call object-oriented programming. It is really kind of the modern paradigm. It has been the paradigm for about 30 plus years. It really got very firmly in place, I'd say in the early to mid 90s, as the Java programming language came up into popularity, because the Java programming language is really all about objects and classes. And if you guys know how to code in JavaScript or C# or any of those styles of languages, this will be very, very familiar territory. How Python employs it, though, is actually pretty unique. It has some interesting quirks, but conceptually, it is identical to the other languages that you may already know. What I'm going to say before I click through on these links here is you could think of a class as kind of like a blueprint, is really a good way to think about it. And you can think of an object as the creation of something tangible from the blueprint that you're looking at. So for example, if I have a blueprint for a house, it's not a house until I build the house following that blueprint. And I could build multiple houses with the same blueprint, but maybe make subtle choices that make them unique. For example, if I build a house, one house might have vinyl siding, the other one might have clapboard siding, or one might have a traditional asphalt roof, and the other one might have a metal roof. Those types of things. But in essence, the house itself is really from the same blueprint. It's its individual characteristics that make it unique, right? So that is a really important concept, to kind of like wrap your mind around. Some other terminology I'll kind of be throwing out there is when we look at a class, which is the blueprint, when we create the object, we call that process instantiation. So an object becomes an instance of a class, right? So put that in your head, maybe take notes on it. I'm going to click through now to W3 schools and we'll take a look at this. I'm nicely zoomed in, just like it was last time. So hopefully we won't have too many ads on the screen here as we kind of flow through this. So let's read through this very systematically and then make sure that we understand what is being presented here. So it says Python is an object-oriented programming language. Very true. And almost everything in Python is an object with its properties and methods. And methods, by the way, is a term that's interchangeable with the word functions. So, and really what a method is a function that's built into an object. A class is like an object constructor or a blueprint for creating objects. So you see how they use the same terminology that I do. So I agree with those statements very strongly, the way they're presented. All right. So to create a class, we simply use the keyword class. And here we have a very, very simple little example. And I'm going to emphasize this is a super, super simple example. So they use the keyword class, they give it a name. I want you to notice that there is a convention in programming that whenever you're creating a class, that you start it with a capital letter, right? Where normally we might start with a lowercase letter if we're creating some other type of entity, but a class is usually denoted with a capital letter. This is true in other languages as well. It's a convention, by the way. It's not a rule, right? It's just a convention that programmers tend to follow. Why? Because that way you can very quickly look at it and go, oh, it's a class. So we have a definition for the class. You give it a name. Notice no parentheses. See that? No parentheses here. Goes right to the colon. And then inside, we have what looks like a variable. And in reality, when a variable is inside of a class, we actually call it a property. and I think of it often as a data field. Like, and this terminology for me comes from more from Java when I think about Java. So we'll have like basically variables that are embedded into a class that give the class its properties. I mean, you can try it yourself, but basically, if you click through here and we print out the class, it doesn't print out the property. It just prints out this like weird thing in angle brackets that indicates that it's a class. And notice it's got this really weird terminology. And by the way, whenever you see these underlines like this related to classes, there's two underlines put together. This is not terminology that we normally execute, but it's just showing that if I'm trying to output the class and we're not looking at the x equals 5 at all, we're just seeing that it is a class and it is the main structure of that class. That's really all that it indicates, right? This is not a good example, I think, by the way. All right, so we can use the class structure to create an object. Now remember, the class is a blueprint. It's not really a thing, right? It defines how we create the actual thing. So in this case, if I want to create a thing that's based on that class, look at the terminology here. We call the class definition with parentheses. The parentheses basically reaches into the class and either using the init function, which we're going to learn about in a second, or the default, which is basically what we call a default constructor function. It builds the object. And then once it's built, we store it into a variable name. So here's an example of how a variable in Python can store a complicated thing. An object is a complicated thing because it can have multiple data properties or variables inside of it. It can have functions, or really what we call methods when they're part of a class. And all of that travels with that very simplistic name. Now, if I reach in there, I define the class. We have a property called X. I create the class, right? This is creating the class, storing it here. So now it's real. It's an object. So P1 is an object based upon the blueprint of the my class structure. And then if I print P1.x, and this is our dot notation, I'm reaching into the object, finding the property called X, and that's what I'm putting on the screen. This is a very simplistic example, but I could, for example, if I add a Y to this, I could also reach into that object and print out Y. So if I run that, you'll see the result. So I can reach in and pull up both of those pieces of information. They are embedded into the object. I can also, for example, make more than one object from the same class definition. So I could have one called P1 and one called P2, and then I could reach in to P2 and pull out the Y. Now I'm going to get the same stuff back on the screen, but in essence, I've created two objects now. Each has an X equals 5 and a Y equals 8. Why? Because that's how it's defined. Often we will control what information goes inside here, but that's coming. So we talked about, this approach here, like when we create an object, we call the object name and use parentheses and it builds the object. But we can also have built into the object what we call the init function. Now, please make a really strong understanding that this is a double underscore, not a single one. So you see as I highlight it, you can see that, right? So a really common mistake when you're defining an object is to use a single underscore, because you kind of look at it quick and go, oh, underscore init underscore parentheses, and then you're like, I don't get it. It doesn't work, right? Well, that's a really common mistake. So I point that out. Those are both double underscores. I don't know why Python does it like this, but this is what they decided. So, hey, this is what we're going with. All right, so let's read what it says. It says the examples above are classes and objects in their simplest form. They are not really useful in real life applications. To understand the meaning of the classes, we have to understand the built-in init function. All classes have a function called init, which is always executed when the class is being initialized or created, right? Use the init function to assign values to object properties or other operations that are necessary to do when the object is being created. What those are depends on what you're creating. You know, the situation will dictate it. So here's an example. And this is more of a tangible example. And by the way, our first lab is kind of built around this concept. So this will be really helpful as we do that. It says create a class named person and use the init function to assign the values for name and age. So you'll notice that we have the class definition, and then inside we create a function. So we recognize this approach, right? So we define it. Init's the default constructor function. It builds the object. So constructor builds the object. That has parentheses after it because it is a function. And it will receive 3 parameters or arguments. And I want you to notice that the first one is what we call the self-referring parameter. So it refers to itself. If you're making a correlation to Java or C#, in those languages, we use the keyword this, which means which object? This object. In Python, we say which object? Itself. You know, this self, me, you know, that kind of thing. Whenever you're using the init function, that's always required to be the first parameter, even if you're not passing anything in there, because it basically what it's saying is like, hey, we created this object and we're going to feed information into it. Which one are we feeding into? This one, itself, right? So in other words, when we send information externally, we will send the name and the age in order to be able to build the object. And then look at the syntax here. So we're going to have this internal property, or if you want to think of it as a variable, that's fine, or a data field. So the object itself will have a name property. And what are we feeding into it? The name that's up here, right? So this name will come here and then feed this property. The same with age, but notice self.age. We would then go ahead and we would create the object. So to create the object, we call the class name. We send in the name and the age. Notice the self thing is not part of it. That's just part of the internal definition. So these will be received. So John will end up here. 36 will end up here. Those are stored inside the object that we just created. And then I can go ahead and access those properties directly using the syntax. I call the object and its name. I call the object and its age. And then those pieces of information can be extracted. Right, so this is constructing the object. Now, of course, you can experiment with this. We're going to experiment with it inside of Visual Studio Code as we're kind of working. All right, so let's move on. And I want you to notice they have a little note here. It says the init function is called automatically every time the class is being used to create a new object, even if you don't define one. It kind of is implied. But if you define one, then you control what information is being put in and how you're naming it. The general convention is it's considered a good idea to have the init function and to define all your data fields inside of it. Now, if you compare this to like C# or Java, in those two languages, we usually create data fields, usually private ones, where you feed in like a string or an integer or whatever it is. And then you have a separate function which is named the same as the class. And then that constructor function feeds into the data field. This is how Python is different. We're kind of defining the data fields in the constructor function as opposed to doing them separately. So any of you that have that Java or C# background, this is the difference. For those, this is brand new to, well, don't worry about it. But I'm just trying to give that correlation that people that already kind of know it a little bit. Now, there's another function here that to talk about the string function. I'm not really super concerned about covering this right now because it doesn't not come into play immediately for us. But it is, if you want to read up on it, you can kind of define it. So they are basically just pointing out that they have this other self-referring string function that allows you basically to output the contents a little bit more efficiently than you would otherwise. All right, so let's move past that. All right, the object methods. Now, this is, we started with the constructor function, and really we should really call it a method, because why? Because it is a function that's inside of an object or a class. So that technically is called a method. But you can also, beyond the constructor, you can also create other functions inside of an object so that when you call upon it, and we are, yeah, and I'm seeing the messages in the chat right now. You guys are saying that I'm breaking up a little bit. Hopefully your internet's good. I'm seeming to get a good stream up, so hopefully, Anandi, maybe it's just on your end. But this is kind of the concept here, where we're building a function or method that is built into the object. So if I wanted, for example, instead of typing a print command to output this string plus the name inside the object, I can just call the function externally. So here we are constructing it again. And then instead of issuing a print command to extract the information, I just call the method inside the object, which does it for me automatically. So here's an example of the object that travels not only with its data properties or data fields, but also travels with capabilities or functionality called methods. And we can utilize those methods. So a well-designed object often will be able to do a lot of things for itself. And this is one of the powers of working with objects and classes. So these are very simplistic examples, but could you imagine if we built an object that maybe had 10, 20 data fields and maybe a dozen methods that are built into it, that would handle most of the functionality you would expect from that object? And you could make a correlation, for example, to something like an automobile, right? So I could go to the car factory and create, that same model of Toyota, for example. And then that Toyota has capabilities, for example, like start the motor, that's built into it. The ability to put it into drive and go forward, that's built into it, right? We wouldn't have to like buy that capability separately. It's part of the object. That's really kind of the thinking here. I won't demonstrate this one. We'll see this one in action. So once again, they make a little note here. The self parameter is a reference to the current instance of the class, right? In other words, to the object that we created, and is used to access variables that belong to the class. So when I here say self.name, which one am I referring to? Well, the one that we sent in here and stored here. So we are referring internally inside the object with that same nomenclature. So in other words, which name are you referring to? Well, this name, right? Keeping in mind that we can take a blueprint and create many houses, for example. This is self-referring. It refers back to itself, and thus the use of the keyword self. Now, they kind of expand on this a little bit. So they keep talking about it, and they say the self parameter is a reference to the current instance of the class and is used to access variables that belong to it. It does not have to be named self, so this is kind of weird. You can call it whatever you like, but it has to be the first parameter of any function in the class. So for example, if I didn't want to call it self and I want to call it my silly object, you are allowed to do that. My recommendation, right, is you don't do that. It is really good to stick with the convention of self. Why? Because other programmers can always look at it and go, oh, I got it. It's self-referring. Yeah, so this is, I think, a weird little example, but they're kind of making the point, right, that you can do that. They take it even farther here, and then they're passing in the object itself and calling it something else. Once again, I don't recommend this approach, but you can do it. So follow the convention is always my thing. Now, whenever we have created properties, we can change them like we can change any variable. Right. So for example, if I create an object called P1 and we set an age for it, and then, the person ages, right? So they started out at 36, but now they're 40. We can reassign it. We can change that value. That is doable. We can also delete object properties, and you can use the DEL keyword. I don't think we're going to have any examples of this here today. I just want you to be aware of it. So that's another thing. You can also delete the entire object. So you can run this code and say, well, okay, I created this object. I use the object to do whatever I need it to do. Now I don't need it. So I'm deleting it to free up memory in my program. So that sometimes does happen. I think in kind of the initial steps that we're doing here, this isn't going to be very necessary. We have also the pass statement. So like we saw this before, right? When we did a function. So if you create a function and you're not using it or haven't written any code for it yet, you can put the pass statement in there just to keep it from erroring out in your IDE. And I think that's all the stuff about objects and classes, right? The other thing that we're also going to do here, and I think we've done this very, very primitively, is to use the import statement in our code. And as we kind of press forward, you'll find there's going to be numerous instances that you need to import capabilities from either somebody else's pre-written code, from a Python standard library, or from something that you've created, and you can import that capability. So what they're demonstrating here is that maybe you would create, something called my module, and it has one function and one dictionary. Now, we haven't learned about dictionaries yet, but think of it as kind of a list. It's kind of a way to look at it. And so this module has a function called greeting, right, which outputs a name. And then we also have this piece of information. Now, if I want to import just the person object, right, so this is kind of a complicated data structure, and I want to import that into my program, I can call the name of the object, which is called my module. Right? This will be a file or a program or a class or an object of its own. And then I'm importing the function or method from inside that object, whatever it is defined at. So this is kind of an interesting thought. So like when we've maybe run some import statements before, like when we were playing with the date time thing, if you guys remember, those capabilities are possible because this is something code that's pre-written. We're reaching into this particular object, technically pulling out one capability from it and utilizing it in our own code. Why? So that we don't have to recreate it. That's the why. There's some syntax that goes with that. We will kind of explore that as we go along. So that's all there is on that one. There's another little link to an external resource here where they kind of get into the documentation of this. And the import statement can actually be used in a few different ways. So I'm just going to zoom in here a little bit so you can see it. In some cases, you might actually import the whole module with, so if it's got like 100 like functions or methods in it, you can bring them all in, right? So that's a possibility. Or if you just want to use one function, you say from this particular module, we are going to import this particular function, right? And that's when you see the from and import used together. Another thing that you sometimes do is maybe you're not sure which thing you're going to use. So this kind of functionally is the same as this, so say from this module, well, import everything for now, right? Is usually how it's used. And then when you figure out that, hey, I'm only using this capability, then you can narrow it down. But sometimes you're not sure and you want all of the capabilities to be present at the same time. So you can use the wildcard or you can just import the whole module. Right? Another trick, and I would say that this is more, and it's not really a trick, it's kind of, once again, a convention, is when you import an external library and you want to use its capabilities, sometimes if that library name is really complicated, sometimes you can abbreviate it. So for example, we might want to import my module, and instead of like typing this out each time in our code, we're going to import it as it's alias of MM. And so in my code, instead of saying my module dot whatever, I'm just going to say MM dot whatever. So these are conventions, very common. So people use lots of external libraries, often kind of alias them, especially when they're doing like data analysis and stuff, um, just simply to kind of make their coding a little cleaner and more concise. You know, just shortens up your syntax. All right, a couple more concepts here before we move on. The next one is this aspect of coding that we call, you know, I'm going to call it error handling is probably the best way to really refer to it. If you've coded in another language, you probably have learned try catch statements, right? So this is really common in the C style languages. It's also common in Java. And basically the way that it works is you have what we call a try block, which is the code we want to run. But for whatever reason, there's a possibility that code might fail. A really good example would be if I'm trying to, let's say, ask the user to open a file and that file doesn't exist, right? We don't want the program to just crash and throw an error message on the screen. We want to keep it running. And so we'll have the try block, which is the code we want to try, and then we'll have the accept block, which is what happens if it fails. And then we can also execute code that executes after it happens when there's no error, or executes code regardless of the results, right? And I'm going to say these two scenarios are less common, but they can be used. So let's just kind of look at it really quickly. And here we have an example where we have a try block where we're going to print a variable X, but we've never defined it. So it would error out and it would just instead print, a simple little message, right? So if we have a piece of information that's not defined, some sort of an input output error, some sort of user input error or whatever, this allows us to handle that and not crash the program, right? So far, it's like if we write code and it fails, it's like, oops, it failed. Let's fix the problem and try it again, right? But that's not really a practical way to write a program. I mean, if you write a program and there's a problem with the code, you want the program to keep running. And hopefully, maybe you would say, hey, you didn't do it right, so please try again, that kind of thing. Or you made an error in how you defined it, or you typed the number when you should have typed the string, or whatever it happens to be. I'm not going to run through these examples, by the way. All right. So if we really dig into this, and we're not going to dig deep at this point, but I just want you to understand that there are different types of errors that we can handle. So if it's a name error where we say that the variable X is not defined, we can narrow down. Another example would be an IO error, input output error, that type of thing. You can read up on this to your heart's content. We're not going really deep here, so that's why I'm kind of skimming over it really quick. The other thing that you can do is if you have a block of code, whether it succeeds or not, you can also add an else statement to it that will output when this works. So this would work, and then this would happen. Right? And then we also have the finally approach that will happen either way, whether it succeeds or fail. Right? This can be useful, especially for getting people back on track if something bad happened. That's my general usage. All right, that's enough on that. Let's go to the continue statement. And I think we looked at this one before, where, if we use a continue statement, it's used to end the current iteration in a for loop or while loop and continues to the next iteration. So if I was like running this loop here and then I becomes 3, we jump out. In other words, we would never reach the print statement and we just continue with the loop. Right? This can also be useful in some of the stuff that we're doing here. So this is just kind of reiteration. Right. That's all our lecture stuff here. Now I want to get into actually doing some examples. So if you have not done so already, what I would suggest that you do is open up whatever coding engine you're using. You will notice that I've preemptively here created a couple of folders for module 4. So if you haven't done that yet, now would be a good time to do it. The way that I did it is I I did it actually through Visual Studio Code. I made sure that this project folder that I have was open. And if your folder is not open, of course, you can go to open folder here and find the correct folder. Once I was in the folder, I used the new folder button inside of Visual Studio Code and created a module for labs and a module for assign or assignment folder. And I would recommend that you keep those two things separate if you possibly can. You can also do the file management within the operating system file explorer if you're in Windows, or Finder if you're on the Mac. That's fine too. And then they should load up here if you go to the right folder. All right, so I'm just kind of giving you guys a chance to do that. I am going to be working in the module for labs folder. And since I think I already know what I want to name this, I'm going to add a new file. And I'm just going to call it module for lab 1.py. So it will be a Python program. Hopefully you guys are okay with this. And let's take a look now at the lab instructions and see if we can start building this stuff. Right, and I'm trying to keep my eye on the chat here too. You guys have been pretty lively in there, but it seems like my bandwidth is okay and you guys are receiving okay. I'm not getting any hiccups on my end, so if you do have problems with the stream, please let me know, because I can always pause. I am recording, so it's not going to be completely lost, but I can understand. Like the answer to number 5 is, and then the stream breaks up. Right? All right. So hopefully that's not happening then. But let's look at the first instruction here. And it says create a class called person, create an initialization function with 3 parameters, self, name, and age, and create properties for name and age. Now this is almost exactly what we saw at W3 Schools. In fact, I think it is exactly what we saw at W3 Schools. So let's jump into Visual Studio Code here and start building. So the first thing that we're going to do is we're going to use the class keyword. Notice all lowercase, by the way. The class is to be called person. Notice the capital P and a colon follow. And then everything that's part of this class structure now will be indented, right? Like any other like indented structure we're using, like if statements or loops or functions. We will create an init method, but I'm going to drop in a couple of comments here to start with. So I'm just going to, if you want to take notes, this is kind of a way to take notes. So I'm going to go ahead, I'm going to indent again here, and I'm going to define the init function. Remember, 2 underscores, the keyword init, and then 2 underscores. And notice what it did all automatically, and I just let it do it. This is Python, the IntelliSense inside of Visual Studio Code, technically. It did have this extra thing here I'm going to remove. But notice how it automatically included the self-referring, property name. So it knows it's pointing to itself. And I suggest very strongly, even though we know we can change it, that you stick with that keyword. We are told to set up properties for name and age, and we are going to feed those in externally. Notice the other thing that it did, how it dropped in the pass statement automatically, since I hadn't defined anything. Why? To keep the errors from happening, basically. If you want to drop in some more comments here, I got a few more that I'm going to paste in, and you can add these if you wish, or not. That's on you. But here they are. So every method or function inside the object needs the first parameter of self. Self is the current instance of the class object. Which one? This one, itself. I know that's really goofy. I'm going to remove the keyword pass here, and I am going to type in self.name equals name. So we'll take whatever sent in and apply it. And then self.age takes the age sent in and applies it to the object. I got a couple of, I'm tempted, I have a bunch of comments that I wrote here that I thought you guys might find helpful. Maybe not, I don't know. So name, I'm hoping to say this maybe a little clearer. So self.name is the scope of the object. Name is in the scope of the object once it's sent in. You can also think of these as properties. And maybe that's a good way to say it. You can also think of these as properties or data fields, we sometimes call them. It's basically variables that travel with the object. And that's good to say. Variables that travel with, abbreviating so I don't have to go to the next line. Also widen my screen a little bit. This is big enough for everybody to see, you guys. It's not too small. Okay, because if it is, just please let me know. All right, so we've done our definition there. All right, so that is really all we're going to create at this point. So let's go back and look at the instructions. The next instruction is create properties for name and age. So I think we completed all of these steps. Right. Now it says create 3 objects, so 3 unique objects using the person class, get user input for the creation of one of the people, output the names and ages. All right, so we'll take these one at a time. All right, so let's now pop out of the object. So now I'm going to go all the way back to the margin. So basically, everything here, and you can see how like Visual Studio Code kind of highlights and indents everything. Everything here is part of the class definition. Now, something I'm going to say right up front here, we're not going to operate in this capacity, at least for now, is it is also possible to take whatever I've highlighted here, create a separate file inside the same folder with the name person, and then import this class and utilize it. All right, so we're gonna do that a little bit later, by the way, but not quite in that capacity, but that's a possibility too. So like anybody who's coded in one of those other languages we've been talking about, that becomes a common practice. And in Java, it's considered more the norm to create an external class file and then import it in and utilize it. Here, it's okay to define the class inside the actual executing program. What I will tell you, as this sits here, the class definition does not execute on its own. It does nothing. It's a blueprint, right? It's kind of like the blueprint doesn't become the house until you actually build it. This is just the blueprint. All right. So now let's go ahead and create some objects. So I'm going to create one for me, right? And so I'm going to call the person class. I'm going to put in a set of parentheses, and I'm going to feed it 2 pieces of information. One is going to be a string, which is going to be my name, comma, and then my age. Yeah, don't believe that. Unfortunately, that's my reality. All right, so that's where I'm at. So there's me creating an object about me. And then, you know what? It says I should print it out. So I'm going to do a print. And now notice what I'm going to do is, what am I going to print? I'm going to print me.name. Right, so I'm going to reach into the object that just created and output my name. And then I'm also going to do a separate print command and say me.age. In fact, let's go ahead and try this and make sure it's even working. Right. So there's the syntax. Here comes the run. So you see the terminal opened up and it's outputting. It's not a very exciting output, but it proves that me is the instantiation, there's some terminology for you, or an instance of the, or object created on the class blueprint of person with these two pieces of information, right? Whenever we send something to construct the person, it goes to the init method, which includes the self-referring variable, passes the information in, applies it to the data properties, and then in the aftermath, once it's created and stored in this variable called me, I can then reach into that object, pull out the particular properties I want, and output them to the screen or do whatever it is I need to do with them. In this case, we're just printing them to show that it works. All right, let's do it again. So let's create a different object called friend. All right, so once again, we'll call the person class. We're going to feed in, and I want you to notice this is kind of interesting, right? Now that it recognizes that I have a class definition, look at what Visual Studio Code is doing. It's coaching me on how to enter the information. Isn't that cool? So it recognizes the object and is telling me how to drop it in. And so that's what I'm going to do. So I'm going to, I don't know, come up with a name here. We have a friend named Greg, and I think his age is really close to mine. I think he's a year younger. Now, once again, I'm going to use the print commands. And instead of printing me, I'm going to switch me to friend. But if you want to really kind of see something interesting, and I know I'm copy pasting for speed, but if I was to type this out manually and I typed out friend and then hit dot, notice that it can reach into the object and recognize the data fields. And I want to choose age. So it recognizes that the object is built and that I can pull properties from it. And if I had methods defined, those would also pop up on that IntelliSense list. All right, so let's go ahead and do this one. So Control S to save. I'm hitting the runtime. Now you can see it's outputting me and it's outputting Greg. All right, we have one more to do here, which is we have to create one now where we prompt the user to enter this information. And maybe, I don't know if this is helpful for you to like separate your objects out, you know, to see them a little bit more clearly, like so. Now, let's create another instance here, and I'm going to call it, how about we call it best friend? Not that Greg's not a good friend, but I'm just saying, right? I'm, you know, searching here. So I'm still going to call the person constructor. So there's my call to the class and the parentheses. And we still need to feed into it the name and the age. But instead of, for example, running a prompt, storing it in a variable, and then pulling the variable in, when I don't really need to keep the variable because it's going to store on the object, I'm going to do the input command right here inside the constructor call. And so I'm going to say, what is your best friend's name? Question mark and space. Outside the parenthesis, a comma, and now we're going to do an int conversion for an input statement because we're going to get age here, right? So we want to convert that to a number. And then we're going to prompt, how old is your friend? Now, this is a series of two prompts, and they're built right into the constructor. So the code's going to execute. It will reach this point. Give me one prompt, we type something in. Give me another prompt, we type something in. Once we have that information captured, then we can output it. So I can just say for my best friend, right? Well, we want to print this, right? So let's print best friend, that name, and print best friend dot age. So that's all the code there, folks. I'm hoping everybody's okay so far. Everybody okay so far? All right. All right. So let's go ahead and give this a run now. And I'm going to scroll up a little bit so we can keep that code on the screen. So I'm going to have to interact here a little bit. Control S to save. Here comes the run. All right. So you can see the first two pieces of information, just we hard coded it and it just did it. So I'm going to click into the console here. What is your best friend's name? And I'm going to say Paul. How old is your friend? And I'm tempted to type he's dead because, you know, he is. But I think he would have been 61 at this point. All right, so it captured it. It put it into the object, retrieved the data properties, and put them on the screen. So that is a significant part of it. And I'm going to just ask really quickly, any problems, anybody? Everybody's okay? I'm seeing mostly thumbs ups and nods here, so that's good. All right. I'm going to switch back over to the module lab assignment here. And we're being asked to do one other weird thing, which makes no sense for what we're doing right now, but is something we're going to use in one of the later labs. So we're going to create it now and let's see what it's asking for. So we're going to actually create a brand new file to do this. So we're going to create a document called helper.py in the same folder. We're going to create a function called getInt that accepts one parameter of prompt. All right, you'll see what I mean by that. This function should loop until an integer is entered. Use this document to validate an age input. Now, we're not going to do that at this point, but we are going to do it later. So anytime that we're going to be trying to validate any sort of an input, we're going to reach this helper function so that we don't have to validate it in the code we're writing. We're going to use the helper thing. And really what we're doing is we're building a file that we're later going to import into our programs and utilize. All right, so let's get busy and do that. So back in Visual Studio Code, so I'm still in the module 4 labs. I'm going to create a new file. This one's going to be called helper.py. Notice all lowercase. Why? Because this isn't going to be a class. It's just a program. We're going to define two functions inside of here. So this will be really what we call a non-executing program, because we're going to write a couple of functions and we're not going to call them to run from this file. We're just basically creating a library of functions is what we're doing. So the first one that we're going to define is going to be called getInt, parentheses, and a colon. Inside here, I'm going to put this name called prompt, because that's what I'm going to have a prompt. So I'm going to prompt somebody for a number, and then it's going to come in here and do the work. Now here's where we're going to use our both a loop and a try except statement. Now watch how this is actually pretty cool the way this operates. I'm going to create a while loop. I'm going to force it to run. I'm going to force it to true and make it go. First, I'm going to try a block of code. What am I going to try? I'm going to set up a variable called user_num, which is going to store the input. And then by virtue of prompting the user, and you're going to see how this is going to work here. All right. First, I'm going to take whatever we capture and it's going to convert to an int. And inside here, I'm going to do an input. I'm going to drop the keyword prompt inside my parentheses. And you see the parentheses are fighting me a little bit there. There's the try part of the block. And if it succeeds, we will return the user number to whatever called it. So I want you to conceptualize what's going to happen here. I'm going to have a different program running. And when I need to prompt somebody for a value, this is going to check to see if the value is valid. And if it is, it'll send back the value. So I don't have to write code in my other program to do that work redundantly, right? But I need to have an except block just in case it fails, right? And then we're just going to put an error message on the screen that says something. Well, last time I tried this, I said, please enter a whole number, right? So I'll ask them for a number and they're going to type in potato, right? That won't work. But if they type in a number, it'll work if it's an integer, right? Or actually, if it's a floating point, it would work too because we would convert it. But if it doesn't work, I want you to think about what happens here. If this code works, we're going to use a return statement and we're out of the loop. If it doesn't work, it'll give us an error message and keep looping. It's kind of a clever little approach. Right. Now we have a second function that we want to define, and that's going to be the one that actually does a little bit of prompting to the user directly. And what we're going to do here is we're going to call this get int in range. So in other words, we want people to enter a value between something and something. So if I have a menu that's got 4 choices on it, I want them to enter a value between 1 and 4. If it had 20 selections, I'd have a value between 1 and 20, something to that effect. So inside here, in other words, we're going to include whatever the prompted value is, the minimum value, so the 1, and the max value, maybe the 4, right? That's going to be most of what our menus are, is 1 through 4. Once again, we're going to put a loop inside here with a try except to prompt the user. Hopefully it works. If it does, we return a value. If it doesn't, we ask them to do it again. And it'll just keep looping over and over again until they get it right, basically. And think about that. That's really kind of the approach of a proper program, right? Like you're running a program, says please enter a number, and you type in your name, it'll ask again. It'll keep asking until you get it right. That's what we're doing here. We're doing it, and I think a way that's very, very efficient, by the way. So once again, we're going to store user num, and then we will do a conversion to int and do an input inside of it, and the prompt will be the prompt. Same thing we did before. But now we're doing a little more processing. We're going to say if the user number is less than or equal to the max number, and that user number is greater than or equal to the minimum number. And I could have switched those 2 phrases. In fact, in my brain, now that I'm thinking about it, I probably should have did it the other way. I probably should have said user number greater than or equal to min, because you think of like going from a minimum to a maximum, not from the maximum to the minimum. But I'm also showing you it doesn't matter what the order is at the same time. So if the number's in the range that we want, then we're going to go ahead and return that user number. Great, we did it right. So let's return that number. We're out of the loop. The loop is now done. But if they fail, which sometimes users fail, right? Well, we're going to put in a message here and say, let's do a print, sorry. Print, give them the message, please enter a whole number. And now I'm thinking to myself, there's another scenario here I'm not thinking about, right? So this would be the error message if they don't enter a whole number, or maybe enter a string. But what happens if they type a number and it's valid, but it's not in range. So I really, the if statement up here should probably have an else now that I'm thinking about it. So let's do that. So we'll put an else, and then we could say print, please enter a number between the min and the max. So maybe we should make this an F string. So I'm going to add the F at the beginning. So I don't have to force the variables in the other way. And we'll use my curly brackets and say between the minimum and the max. That probably should put in some punctuation too. All right. So I think, all right, I'm looking at my example here, and this is all we're going to need here, right? So this is going to become our library of functions, right? We're not utilizing it yet, but we will be utilizing it as we go forward. So you can actually go ahead now and just save that. Now, I'm getting one error here, and I'm trying to figure out why I'm getting an error. Let's see what it says. Indented block. Okay, so where's my indented block problem here? Try, we got our if. That looks okay. I'm just looking at my example and trying to figure out where am I failing. Oh, you guys see what I did? I see what I did. I accidentally deleted my except from up here. Remember? Remember I had that in there? And so that's why it's throwing an error. So I deleted this by mistake. That's why I got an error message. Really what it was saying is that, hey, you got an except here, but you don't have anything in there. So I could have said it a little bit better. So this is the completed helper pi function. And now when looking at the clock, we're already an hour in. We're going to do a quick 5-minute break, folks. So it's 7:03 right now. Let's come back at 7:08. I'm going to pause the recording and we'll continue on from there. All right, we're going to move on now to module 4, lab 2. So moving on to the next screen. And this is about methods and iteration, you know, so here comes some of those terminology things. The documentation link that we have here takes us to stuff that we've already looked at. The thing that I'm just going to kind of put in your head as we're doing this is, you know, we are learning a lot of terminology here, right? And if this stuff is brand new to you, if you're brand new to programming, that terminology can be confusing, real frankly, right? Yeah, I was kind of, you know, tell students when I first learned about objects and classes, man, it just did not stick. I just, and in all fairness, I think that maybe I was just instructed poorly, you know, like, because maybe my instructor didn't really get it either, you know. But now that I have a really firm understanding of this kind of like blueprint and actual object, you know, this kind of concept, you know, it helps to kind of break things down. Remember, methods refer to the fact that we are using functions from an object that we've built from a blueprint, right? So it's still a function though. So very often you hear programmers interchangeably using those two words. It's a method, it's a function. Technically, a method is a function from an object or library. Iteration refers to when we are going through and looping, and one instance of a loop is to iterate. And then if we're looping over and over again, we are reiterating, but iteration is the process of looping. It's kind of the fancy programmer way. Don't let the terminology fool you. They're really kind of basic words, but it's always kind of like the acid test that programmers will do with you to see if you're in the know. You know, oh, I see you're working through some iterations. Ah, you mean you're looping, right? So don't let the terminology ever sway you. All right, here goes into the next module here. So now we're going to work on this next little thing. So we're just going to kind of keep ramping up our object and class skills here a little bit. And it says create a class called pet. Create an initialization method with 4 parameters. So self, name, species, and sound. Create a string method to output all three parameters. So we're going to do that little thing that we kind of skipped over, but you'll see it. Real frankly, I think it's easier to understand in doing rather than reading the definition, which is kind of why I did it that way. And then create properties for name, species, and sound. Okay, we'll do that inside the init method. And then create a method called speak that will print out what the species is and the sound that the pet makes. For example, if the species is dog, it would go woof, or whatever, right? And then create a list of at least 3 pets. So we're going to put those into, a complicated data structure. And then we're going to iterate through the pets one at a time in the list, and then use the string method or the str method to call the speak method. And we're going to do it so kind of like automatically. So we're going to combine a number of different skills here. So the combination is basically going to be this: create a blueprint, create several objects. Those objects, instead of being individually stored in variables, are going to go into a list structure. So a list, so this is an important concept, a list can store objects. And each one of those objects can have its own data fields and its own methods. Kind of powerful when you start thinking about it. And then we're going to use a loop to traverse that list and all the objects and extract their information. Powerful stuff, folks. And what's even more amazing about this is how little code you need to actually make it happen. So, and then we'll say, hey, that's the power of Python. All right, so I'm inside the same folder still. I'm going to create another new file. So this is going to be module 4 lab 2.py. And I'm looking at my code here. We are still not going to use that helper program, but we'll use that in subsequent. I think the last 2 labs both use it. If you're waiting for that moment, it's coming. All right, so first let's start by building the class called pet. Notice the capital P, right? We're going to define an init function, so underscore init, and see I'm letting the IntelliSense guide me here. I'm going to remove this little lambda expression, which is what that's called, by the way. And I'm inside the parentheses, I'm leaving the self, but we're going to include name, species, and sound, as we were instructed. I'm going to remove the pass, and now I'm going to create 3 self-referring properties, one for name, another for the species, and then another for the sound. Right. That's the init function. Now we're going to go ahead and define what we call the string function, or the str, if you want to call it that. We're going to include the self-referring. And now we're going to define this. Oh, you see why it didn't auto type for me? I think it's it's not a def, it's a dir. That's actually kind of funny. I thought it was funny, but I'm going to go back and let it do the autocomplete here, because I was wondering why it wasn't popping up. I'm going to remove the lambda expression. I'm going to remove the pass, and we're just going to type in a simple return statement here. We'll do an F string approach, and it's going to just say first the self dot name. We'll put in a space and say is a self dot species. So for example, my dog's name is Abby. She is a dog. So it's going to say Abby is a dog, as opposed to Mojo, who is my cat. Now I do have parentheses around this, and that is incorrect. So because really we're returning this, which is a string. So that's going to drop into another object for printing. So that's the definition of that method. Then we're going to also define a method called speak. So this is like a regular method. There's no double underscores here, right? It's kind of a normal kind of function. We're still using the self-referring. And then we're going to have this one directly print a statement. We're going to use at the F string approach again. And here I'm going to do self dot species goes self dot sound, right? So dog goes bark or woof or whatever you want to call it. If you ever want to do a really interesting study, so here in the US, like you say, what sound, like you say to your kids, what sound does a dog make? Right? And we say woof. What sound does a cat make? Meow. Ask somebody from a different country what sound animals make, and they have a different way of doing it. And I think it's really fascinating. Like in Greek, we say, like, what sound does a dog make? And we say rav. And then what sound does a cat make? And we say meow, right? It's not meow, it's meow. So whatever. I think it's really pretty fascinating. All right. But this will adjust. All right. So this is our class definition, folks. I'm going to come out, go all the way back to the left margin. So our class is now defined. Remember, that's the blueprint for the object. We then need to create some object. So let's do this. I can go my first pet. And so I can create the object, use the constructor, right? And see how fast I did that? It didn't even give me a chance. Right, so there it is. And then I'm going to go ahead and, I'll use my dog as an example. It's Abby. She is a dog. And she says, woof. Bow wow, or whatever. Actually, she doesn't really bark much. She howls. So she does this thing where she goes, "Arr!" I swear sometimes she's talking. I don't know if your pets are like that, but they can get quite animated. And then I'll have, let's say, another pet. And once again, we'll call the pet constructor. And then I'm going to say Mojo. Mojo is a cat. And Mojo goes meow. And you can get much more colorful. Dog, I have a cat. All right. Then I'm going to build a list. Okay, so I can do this and say, I'm going to build a list called pets. And inside that list, I'm going to place my first pet, comma, another pet. So now think about this. I have complete objects inside here that come with their data fields, their properties, with a couple of methods built into it, and it's all stored right here. And we can use one variable name to store multiple objects. Think about the layers of complexity here. I mean, this is really powerful. And for those of you that have done this in other languages, you see how Python is like significantly much simpler in the execution of doing these actions. One thing that I do see a lot of programmers doing too, right? And I think it's kind of worthy to mention this, is a lot of programmers, especially if they have a long list of names, will kind of start to format it like this. It's still functionally the same, even though it's split across different lines. The square brackets are kind of irrelevant. Right, so we have now created two objects, right? my first pet, another pet. We put them in a list. But now I'm going to create a third one because I don't know if you guys caught that instruction. So I'm going to say pets dot append. So append is a method where we can add stuff to a list. Now that's basically a method, right? Relative to lists. And then inside that append, I'm going to call the constructor for pet and feed in another pet. So I have another pet. We're a multi-pet household. I have a few cats, a dog, and we also have an Amazon parrot, which is a really weird pet to have. And by the way, parrots have a very long lifespan. We got her from an old man who passed away, and she was adolescent at the time, but they have a lifespan equivalent to humans. So we've already made arrangements with our children that when we pass, who's going to take Poco? Because she will probably outlive us. Okay, so she is a parrot, an Amazon parrot, if you're curious. I think they call her a mealy crown Amazon or something like that. And I'm not sure what sound she makes. She can sing and talk, by the way. How about she makes the sound caca? You guys know where that comes from. There's a really bad movie where they do that. All right, so there's another object now added to the list. So this is kind of interesting. So I've created two objects, added them to a list. Now I'm using the append command to add another one to the list. So really, if you can envision this, there's another pet added. And here's the difference to this. This one doesn't have a name. I didn't put it inside of a named object. But it's still in the list, by the way. All right, so now I'm going to create a loop that's going to step through that list of objects. So for each pet in the pets list, I'm going to iterate. Right? So I'm going to print the pet with all its stuff. Right? And so what this will do, so just to understand how the string method works, the double underscore one, when I just say print the pet, if it's not defined, it would print it out with all its complexity, and we kind of saw that before, and it looks kind of messy and ugly. Makes no sense. But if I have a string method defined, it will print the name and what it is. And then if I want it to speak, I'm just going to say pet.speak with parentheses. And so, for example, it'll reach in for the first time through and say, Abby is a dog, woof. Right? So this will do Abby as a dog because it reaches to the string method. This one will reach to the speak method. And actually it'll say, dog goes woof, is what it'll say. Or parrot goes caca. The parrot, by the way, loves to sing along with opera music if you play it for her. She thinks she's one of the singers. Just very amusing, very, very amusing, and also very loud. All right. So just as an example, we can also reach into any of these and specifically pull out any of these components we want. So I'm just going to throw that in at the end. This is the entirety of the program, folks. All right, so I'm going to scroll a little bit on the code to make room for the console, and then I'm going to go ahead and run the console. Here we go. Control S to save on the code. Hitting the run button, in principle, should save, but doesn't in this IDE. So it says Abby is a dog, dog goes woof. Mojo is a cat, cat goes meow. Poco is a parrot, parrot goes caca. Cat goes meow. And so there's my output and a successful run. Hopefully it works for everybody. I'm going to pause here for just a moment.